So for this school trip, the cost is $16 each for a child and $24 for adults. Question, what's the ratio of the number of children to the adults? I'm going to call C the number of children, A the adults. This is what we need. Statement 1 says the ratio of the total cost of the trip for all children, which would be number of children times the price of each ticket. That's the cost for all children for this trip. And then divided by that for the adults would be number of adults times the cost of per adult. And that's 8:3. So you'll notice we can get to this ratio C over A. You don't have to compute it, but at this stage we already know we have a unique value for that. If you want to do this extra work, you could. That ratio is 4:1. One alone is sufficient. Statement 2 says the total cost of the trip for all children and adults together was $2,200. So this would mean 16 C plus 24A is 2,200. And I can reduce this, divide both sides by 8. 8 times 2 is 16, 6, 4, so that. And this is going to give you multiple values. If you are uncertain, because sometimes these equations where C and A are integers can have a unique solution. It depends on the context. But here, we will have multiple values. So 275 minus 3A, and I can kind of quickly show you how. So for example, if A is 15, there are 15 adults, this would be 275 minus 45, 230. Yeah, that's 230 divided by 2. So C would be 115. So this would be one ratio, 115 to 15. If I picked A to be 25, then C would be 100. In this case, the ratio would be a different value. This is the 4:1 that we got here, but this would be 5 times 2, 23:3. So we have two different values for the ratio, and that means 2 alone is insufficient. So I did this extra work because I've had students ask me this question. Can we just assume at this stage that we have multiple values? In general, you can, but sometimes whenever the integers are constrained to be when the variables are constrained to be integers, sometimes you can get a finite value, especially if this was a smaller number. So you do want to be a little bit careful. But in this case, 1 alone is sufficient. Answer is A.